Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of complex numbers. We're just beginning with this chapter, so please understand the brief synopsis of this chapter. First of all, what do you mean by a complex number? Any number of the form a plus I b, where a and b are real numbers and iota is equal to square root of minus 1. So, that is said to be a complex number. Okay. So, any number of the form a plus ib. So, if you are taking z, that is the notation we use for a complex number, right, and the set of all complex numbers we usually denote it by c. Okay. Now, if z is a plus ib, then what is the real part of this complex number? The real part of the complex number is a and it is denoted by Re of z, and the imaginary part of this complex number is b. It is not ib, it is only b. That is the imaginary part of the complex number and it is denoted by Im of z. Well, so that's about the notations. Now, when do you say two complex numbers are equal? So, two complex numbers are equal if and only if a is equal to c and b is equal to d. Okay. So, if this a is equal to c and b is equal to d, then complex numbers are equal. If the complex numbers are equal, then this follows. So, it is if and only if. Then multiplicative inverse of z. What is the multiplicative inverse? Additive inverse is minus z, that is simple, there is no confusion about it. Now, what is the multiplicative inverse? It is 1 by z, okay, and that can be written as the conjugate of z divided by the modulus of z square, okay, and that is equal to a minus ib, that is the conjugate, right, divided by a square plus b square, that is the modulus square. Well, so that is about the multiplicative inverse. You can just remember this formula and get the answer very quickly. Otherwise, you have to divide and then multiply and divide by the conjugate of z, rationalize it and then simplify. Then also you can get the answer if you don't remember the formula. Well, so let's move on to the next concept of complex numbers. In this class, let us understand what is the modulus and conjugate of z. If z is a plus ib, a complex number, then the modulus of z is denoted by, okay, so this is a symbol mod z, you can read it, is equal to square root of a square plus b square, and that is the modulus of the complex number. And what is the conjugate of the complex number? It is z bar, and that's equal to a minus ib. Only the imaginary part changes the sign, whereas the real part remains the same. B becomes minus b, that's it. Okay. Then there are a few properties which are satisfied by the modulus and conjugate of complex number. So, if you have multiplication of z1 into z2 and then you take the modulus, that's same as taking the modulus separately and then multiplying them. Okay. So, similarly for division you have this property, and for conjugate, z1 z2 whole conjugate is equal to z1 conjugate into z2 conjugate. Okay. And similarly, if you have addition, then you will have addition here. If you have subtraction, you will have subtraction here. That means conjugate can be separated and found separately. Now, if z1 and z2 are two complex numbers, then these identities satisfy, which you know already. z1 plus z2 whole square, okay, z1 minus z2 whole square, then this will be minus, okay. So, z1 plus z2 whole cube, that is the formula, and if you have z1 square minus z2 square, z1 plus z2 into z1 minus z2. So, these are the identities. So this is about modulus and conjugate of a complex number. So let's continue. Hello dear students and welcome to JEE and CET classes of complex numbers. Now let's discuss a few important points of quadratic equation. See, a quadratic equation in general can be written as ax square plus bx plus c is equal to 0. Then its roots are given by, if they have the real coefficients, that means a, b, c are real numbers, then the roots are given by minus b plus square root of d divided by 2a and minus b minus square root of d divided by 2a, where d is equal to b square minus 4ac, and this d is called the discriminant of the quadratic equation. Well, now if b square minus 4ac is 0, if d is 0, then what happens? The roots will be minus b by 2a, minus b by 2a, both are same, correct? So you get equal roots, and then both are real roots. What happens if this d is greater than 0 and all the coefficients belong to the rational number, a set of rational numbers, okay? Then the discriminant also belongs to the rational numbers, hence alpha and beta are rational and unequal, okay? So you get one number here and you get a different number there if d is a perfect square, okay? So first of all, a, b, c must be rational numbers, and this d must be greater than 0, positive, and d must be a perfect square. Then you get rational roots and both are not equal, unequal roots, alright? So you get rational and unequal roots. What happens if that is greater than 0 and it is not a perfect square? If it is not a perfect square, you don't get rational roots, you get irrational roots. You get square root of 2, square root of 3 and all such multiples, okay? Square root of 17, square root of 13, anything like that. It's not a perfect square. Even square root of 15, okay? If you have square root of 16, then that would be 4. You get rational. Otherwise you get something within the root, that would be irrational, and they are not equal, they will be unequal, all right? Then finally see, we have seen if d is equal to 0, if d is positive, perfect square and not perfect square, and if d is less than 0. So if d is less than 0, then the roots are complex. So if this is less than 0, that means it is negative. Within the square root, if you get negative, you express in terms of iota, I, correct? So that is a complex root, and both will be conjugates of each other, because if you have a plus ib type here, you will have a minus ib type here, because you are getting I only here, correct? So only imaginary part will change the sign, so they will be conjugates of each other. Well, so let's continue. We'll discuss about polar representation of a complex number in this particular video. The polar form of z is equal to x plus iy, so that's the complex number, is z is equal to r cos theta plus I sin theta. In short, it can be written as cis, okay, cis theta. So that means cos theta plus I sin theta. Okay, so that is the short form of it. Now r comma theta, if you write in the ordered pair, it is called polar coordinates. What is r? R is the distance from the origin to the point till the complex number, okay? So here the axis is real axis and imaginary axis. This is the Argand plane or the complex plane, okay? So that is the modulus. So modulus of z is nothing but r, that is square root of x square plus y square. And what is the angle here? The theta is the angle between the positive x axis till the complex number z, all right? The line joining origin and the point which represents the complex number, and they have two names. One is argument, another it is also called as amplitude. So amplitude or argument is theta, and in short it is written as arg of z. So that is the notation we use for the angle theta. Now here, what is tan theta? Tan theta is opposite by base adjacent y by x, correct? So therefore theta is nothing but tan inverse of y by x, take within the modulus. So now we have four quadrants, we have four different quadrants, and if the complex number is in the first quadrant, that means x is positive, y is also positive, correct? Then how do you find if x is positive and y is positive? Theta is nothing but alpha itself. So what is alpha? Alpha is tan inverse, okay? You take this as alpha, okay? So alpha is tan inverse of modulus y by x for this practical requirement. All right. So and theta and alpha are both are same if it is in the first quadrant. So you can take either theta or alpha, doesn't matter. But when we go to the next, it matters. Therefore, I have changed that to alpha now. All right. Now, what happens if the complex number is here? Okay, complex number is here. Then this would be your angle between the positive x-axis to the line joining origin and the complex number. Okay, the point which represents complex number. Then theta will be pi minus alpha. Okay, so second quadrant theta will be pi minus alpha. X is negative, y is positive. Okay, so theta is pi minus alpha. All right, and what is alpha? Tan inverse of y by x, that is same. Then if it is in the third quadrant here, that will be, if you are going this way it is positive, if you are coming clockwise the angle is negative. So here the angle is negative of pi minus alpha. So second quadrant it is pi minus alpha, third quadrant it is minus of pi minus alpha. And if it is in the fourth quadrant, then here theta alpha, and if you are coming back it is minus alpha. So that is minus of this quantity, minus alpha. So these are the four formulas that you have to remember. Specifically these things you got to remember for any problem based on polar representation. Well, so next you have a few properties of this argument, and then we will begin to solve the example problems. So thank you for watching this video. So please go through it very carefully, note down the points and be ready for the examples. Properties of argument. We have seen in the earlier class how to find the argument or theta of a complex number. Well, now let us look at some of the important properties which will help us in solving the problems regarding argument of a complex number. First of all, if you have multiplication of two complex numbers z1 and z2, and then if you want to find the argument of it, you can simply find the argument of the first complex number and argument of second complex number and add those angles arguments. And if you want to find the arguments of z1 by z2, you just have to subtract the arguments of z1 and z2. And then if you want to find if okay, argument of z1 by z2 is theta, then what will be argument of z2 by z1? If you reverse it, it will be negative. So that is a important property, and this is another important property, argument of z bar, that is negative of argument of z. Z bar is conjugate. Okay, if z is a plus ib, this is a minus ib. So you will have it in the negative side. Okay, because the imaginary part is changing the sign. Understand? Z is a plus ib, or I will take x plus iy. Okay, so then you have the argument in the first quadrant, correct? So this is x comma y. X is positive, y is positive, both are positive. Now what is z bar? Z bar is imaginary part of the complex number changes the sign, right? So real part remains the same. So here x is still positive, but y has changed the sign. That means y is negative. It will be in the fourth quadrant, right? So if it is in the fourth quadrant, this is minus theta. So argument of z bar will be minus of the argument of z. Well, then argument of z by z bar. So what is argument of z by z bar? Using this property, if you have z1 by z2, then argument of z1 minus argument of z2. Therefore this will be argument of z minus argument of z bar. Then what is the argument of z bar from the previous property? Argument of z bar is minus of argument of z. Hence it will be plus. So therefore it will be 2 times argument of z. Therefore it will be 2 times argument of z. I hope you understood these properties. Okay, so we'll use them in the problems, and these properties will help us to solve the problems based on argument very quickly. Well, so now let us begin the examples.
Don't forget to like our video and subscribe our YouTube channel for all the updates.